Hey everyone, welcome back to our channel. If you are navigating your way through world of data science, you have probably came across categorical data, those non-numeric features that represent categories or groups. Today we are going to take deep dive into categorical encoding, which is essential process of converting these categories into number that machine learning algorithm or model can understand. By the end of this video, you will be well equipped to handle categorical data in your projects. So let's dive right in. Let's start by understanding what categorical data is. Unlike numerical data, which involves number, categorical data is made by categories or labels. For instance, color can have categories like red, green, or blue. Similarly, education level might include high school, bachelor's, or master's. These categories are essential for capturing the diversity and complexity of real world data. Categorical data can be further divided into two types. First, nominal, second, ordinal. Nominal data has categories without any inherent order, like color or types of animals. On the other hand, ordinal data has a specific order or ranking, such as education level or rating. So, why do we need to encode this categorical data? The reason is simple: machine learning model, especially those based on mathematical equations, need input to function, need numerical input to a function. If we feed this in model raw categorical data, they won't know how to process it. Categorical encoding is the key step to transform these categories into numerical values. Think of it like most algorithm works by equation like y is equals to mx plus cy is equals to mx plus cy is equals to mx plus c. Here x represent the features which must be numerical for the math to work. Encoding categorical data into number ensure these features can used in this equation. Now that we know why encoding is necessary, we will explore its methods to do it. First is label encoding, second is ordinal encoding, third is one hot encoding, and fourth is target encoding. Each method has its own use case and application. We will explore it. First, let's talk about label encoding. This method assigns a unique integer to each category. For example, if we have color like red, green, and blue, they might be encoded as 0, 1, and 2 respectively. It is straightforward and easy to implement. However, there is a catch. Label encoding can introduce unit and ordinal relationship. For instance, the algorithm might interpret blue as being greater than red simply because 2 is greater than 0. This can skew the model's understanding, especially in case where the categories don't have any natural order. Next up is one hot encoding. Instead of assigning a single number to each category, this method creates a new binary column for each category. So if we have red, green, and blue, we get three new columns for each for one color, where 1 indicate the presence of that color and 0 indicate its absence. One hot encoding prevents the unit and ordinal relationship we discussed earlier, but it comes with its own downside. It can lead to high dimensionality feature space, especially when we are dealing with categorical feature that has many categories. This is known as curse for dimensionality, and it can make model more complex and slower to train. Ordinal encoding is used when categories have specific order or ranking. For example, consider a feature education level with categories high school, bachelor's, and master's. Here it makes sense to encode high school as a 1, bachelor's as a 2, and master as a 3 because there are natural progression in level of education. This method is particularly useful when order matters, like in survey responses where options range from strongly disagree to strongly agree. But remember, ordinal encoding should not only be used when there is a genuine ranking involved or general order is involved. Target encoding takes more advanced approach by incorporating information from target variables. This method replaces each category with the mean of target variable for that category. For instance, if you are predicting house price in cities like New York, Los Angeles, and Chicago, it might encode with their average house price. While target encoding can be powerful, it is also prone to overfitting, especially in a small data set. The model might learn pattern that only exist in a training data, leading to poor generalization on new data. It is often used in competition and complex model, but careful required. It is required careful handling. It required careful handling. So, how do you choose the right encoding method? It depends on several methods or factors like the nature of data, the type of machine learning model you are using, the problem you are trying to solve. For example, use one hot encoding when dealing with nominal data for tree based models, or ordinal encoding for ordered category. Target encoding is a powerful but should be used with caution due to its tendency to overfit. So that is it for today's video on categorical encoding. We have covered the basic, explored different encoding techniques, and walked through a real world data set. I hope this video has made the topic clear and actionable for you. If you have enjoyed this content, don't forget to like, share, and subscribe for more deep dives into data science. See you next time. Thank you so much. Thanks for your time.